Welcome to breakout sessions for Weeds, Pest, Pathogens track. Before I introduce today's speaker, I'd like to mention that there will be one CEU in crop management available for attending this breakout session. We will have details at the end of this session for offering the CEU on how to access those credits. We appreciate the opportunity to partner with CCAs to offer this additional benefit. I'm happy to introduce Dr. Nathan Kleczewski, speaking on seedling diseases and seed treatments. What's the deal? Dr. Kleczewski is a former assistant professor and extension field crop pathologist at the University of Illinois Urbana-Champaign. His work focuses on identification and management of problematic and emerging disease issues affecting producers in the region. He held a very similar position at University of Delaware from 2013 through 2017 and worked in fungicides, nematicides, and biological discoveries at FMC from 2012 to 2013. He earned his Ph.D. in Plant Pathology from the Ohio State University in 2009 and spent time as a post-doctoral researcher at Indiana University and at Purdue University. Dr. Kleczewski grew up near Sheboygan, Wisconsin, and is a big Green Bay Packer and Seinfeld fan, which he enjoys watching with his children and his spouse, even though the feeling may not be mutual.
Thanks for that introduction. I got a lot of good material to share today. And as usual, I know there's some people that are very experienced and knowledgeable, and maybe some of this stuff is new. So I try to put a little bit of everything on there so that everybody has something they can take home with themselves. So I just want to talk a little bit briefly, just to put us all on the same page. What are some generalities about seedling diseases? First off, they're all soil-borne, so these aren't going to be spread by spores that are being shot off by special structures or anything like that. These persist in the soil, and they're going to be attacking your emerging soybean seedlings before or after they start to emerge. They're all favored by wet conditions. So really it's that wet, rainy periods right around planting that's going to favor all seedling diseases. And then there's other characteristics like temperature or soil type that can, potentially make some diseases pop out more than others. Also, they have to be in your field, right? In terms of how they're causing issues in your plants, they're either preventing the emergence of your seeds or they are killing your seedlings outright soon after emergence or germination. Now, if those plants survive that early infection, they can get infected later, and sometimes that can result in reduced nutrient acquisition, water acquisition, which can translate into reduced yields in some cases, okay? So what we're doing when we're managing our seedling diseases is we're trying to really facilitate the growth and germination of those seedlings, because as soon as those true leaves pop out and those leaves start to produce photosynthate, they're going to allow those root systems to grow and expand and then outgrow any potential infections. And that's when we see, the best benefits of seedling management is when we're going to be really promoting the germination and growth early on in the season. So in terms of managing diseases, seedling diseases, we've shown through research year in and year out that the best, most profitable, and the most efficient way to maintain productivity and minimize seedling disease issues is to utilize an integrated management strategy. And so this includes cultural practices, rotation, irrigation management, planting, those different things. And of course, these can differ by disease. Host resistance when appropriate, and only is applicable to certain types of seedling diseases. Seed treatments can be useful as well, but we have to keep in mind how those work and how to select them. And biological control organisms. These could be inoculants. These can be manipulating your soil environment so that there's just more diversity in the soil. Now, the thing we have to keep in mind, biological control, those are living organisms too, so we don't tend to see as consistent of a response. But anytime we're improving the diversity of the soil microbes, it helps our management of our pathogens, because soil pathogens are not typically very good competitors. Now, in terms of seed treatments, I just wanted to bring this up first because I know there was some initial questions that came in early about seed treatments. So I just talk about this in general. They are one component of that integrated pest management strategy. They help to improve that germination of the seed, okay? So they're protecting that seed when it's in the ground from any pathogenic organisms that could cause a seed rot or could cause a seed blight. They work for 3 to 4 weeks typically, and then after that point in time, you can't really be expecting those seed treatments to be providing you much benefit. So what they're not doing is they're not fumigating soil, okay? They are just existing in the immediate root zone. Some of those active ingredients, depending on how they work, can be taken up into the germinating seedling tissue and then move into the foliage as well as into new roots. But we have to remember that these are not just going to kill all the pathogenic organisms in the soil. If those organisms aren't active at the time the seedlings are planted, like for conditions I talked about, maybe the moisture's not right or the temperature's not right, those seedlings won't have an activity, and they're definitely not going to cure dead seed. So if there was a germination issue with your seed batch, they're not going to just magically pause to germinate. What they'll do is, again, protect those seedlings from those organisms nearby in the soil. So there are factors that can influence the fungicide seed treatment utility or efficacy, so how well they work and how they work. Again, I mentioned the active ingredients, so there are specific fungicides that are there, what they're targeting, their mobility in the soil, if they're systemic or not, as how broad their spectrum are. So some active ingredients are very targeted. They might only affect one pathogen, where others might affect multiple. Soil characteristics are also very important, in particular organic matter. So organic matter will lock up these active ingredients once it comes into contact with them. So typically, the more organic matter you have, the less these chemicals will move in the soil and the less activity they'll have as well. Temperature, soil texture, all these other things can have impacts. And one thing that we have to keep in mind too, just like with pathogens, with fungal pathogens we encounter on the foliage, we do get resistance in our soil pathogens as well. And I'll have some examples of those as we come up here. So if you're thinking about things that would increase your risk for potentially needing a seed treatment and breaking even, or even having, you know, an improvement of profitability when you use these things, these are some of the, I guess, the five big rungs on the ladder. First, you need a history of seedling disease, so you've confirmed it's an issue in the field, you know what you're dealing with. You're planting a susceptible cultivar. This comes into play especially with SDS and Phytophthora. Continuous soybean production will increase those seedling disease populations or pathogenic populations. No-till production, a lot of times the soybean residue can host some of these diseases like charcoal rot longer, but also it can serve as a resource for some of these pathogens, in addition to helping to hold in more moisture in the soil. And I mentioned that's important for these as well. And then the cost of seed and seed treatment, yield and sale price. I mean, that's really the big thing. You know, how much does it cost to put that seed into the ground with that treatment, and what's the benefit you're getting back in terms of protecting that yield? So in terms of best management practices, we know that integrated management is the way to go for most of these diseases. So what I'm going to do now is go through our big diseases that we have in Illinois and talk a little bit about how to diagnose those as well as manage those. And I'm going to start off with sudden death syndrome, move into RHIZOCTONIA, a little bit of Pythium, and a little bit of Phytophthora. Now, sudden death syndrome is caused by Fusarium species. Now, that's a unique Fusarium, Fusarium vergaliforme. There's lots of other Fusarium out there that do not cause sudden death syndrome, so keep that in mind. Wet conditions, but in particular cool conditions, as that seedling starting to germinate, are going to favor infestation or infection of the roots by this organism. So it grows better under cool conditions. It actually does cause a seedling disease, and a lot of times we forget about that. So if we have a susceptible host and we have factors that really increase the infection early in the season, you do get reductions in your stand, and you do get some seedling blights that occur. If those plants survive that early infection and later in the season, as the pods start to fill, say R3 or so, we start to get fluctuations in wet and dry weather. That tends to result in the production of a toxin by the fungus that's infected that root. It moves up the xylem and it starts to accumulate in the foliage, and it actually causes damage to the photosystem. So you start to see that interveinal necrosis and death of the foliage associated with that. So I believe I gave a talk on how to diagnose interveinal necrosis in soybean seedlings. That's something that's shared by several other pathogens, but in SDS, it's really the hallmark. So this is what that looks like. So the veins remain green, and then you start to see that necrosis or chlorosis. Many different diseases and other issues such as pesticide toxicity or even herbicide toxicity or damage can cause similar symptoms. So we have to make sure we're going into our field, getting out of our truck. You're going to split those stems, and I say pick about 12 healthy looking plants, 12 ugly looking plants, split them down, look around the soil line. And if it's SDS, typically what you see is this brown symptom within the stem, but then the center of that pith is going to remain nice, white, and healthy. If you get out in the field and it's been cool and humid, you might even see blue growth on the roots as well as that lower stem. If you have a pin or a toothpick and you can pick those off and look under a microscope, some of you might have one in your offices or even in your truck, what you'll see are these blue boat-shaped spores, and that's really the hallmark of this disease. Now, one thing to keep in mind, at full seed, at R6, there's a 7% reduction for every 10 unit increase in what's called the disease index, or the DX. And so those of you that were all-star wrestling fans in the 90s, there was the DX group there. So I always think about that when I talk about DX. But anyway, it's basically the incidence of the number of plants with SDS times the amount of foliar symptoms, and that's on an ordinal scale. So it kind of gives us this value. The higher the value, the more susceptible, the more damage. The lower the value, the less susceptible. Because if we're losing foliage, if that starts earlier in the season, we're losing photosynthetic area, pod fill, all those things. So that's why this tends to be our rating for SDS. Now, what about management? What do we know? First off, cultural practices. And the old thinking was, if you plant earlier, you're more likely to get SDS. Well, now we know through research that, one, we can't control the weather, right? And we are showing that in some of the work, especially this one this particular publication that came out in 2016. In this case, they were looking at multiple, I forget exactly how many sites, but you're talking about multiple years, multiple locations. And what they're seeing is that you look at the planting date and you're looking at the different sites here. A lot of times there isn't any significant difference. And when we do see significant difference, it's not that the first or second planting dates were the ones with the highest amount of disease. That's what this number is showing here. Sometimes it's the first, sometimes it's the third. It depends on the location in the year. Correlation is not consistent, meaning that the planting date is not really going to be influencing the amount of foliar disease, because you never know when it's going to rain, right? So planting on time, getting the seeds out of the ground should be the focus in terms of managing this disease and making sure that you have it diagnosed correctly. In terms of resistance, this is a disease that can be managed very effectively with resistance. It's what we call quantitative resistance, which means it exists on a spectrum of highly resistant to mildly or moderately resistant, okay? It's controlled by a large section of the genome, multiple genes. It's not complete immunity. It is going to give you, it's going to reduce the ability of the fungus to colonize and grow and produce those toxins that move into the foliage. But once breeders do find cultivars that have those traits, it's very heritable and it can be moved into subsequent varieties. One of the things we notice is whenever there's a new trait, especially for herbicide resistance or something like that, that emerges, we see shifts in the type of resistance responses we see in our soybeans. So this can be kind of demonstrated in some of the old work back in the day from Southern Illinois University. So here we're looking at some early group 4s. The susceptible check had a DX score of 50. Okay, so anything on that susceptible check or to the right would be considered to be susceptible to sudden death syndrome. If you go to the left, especially in you're in that 1 to 10, 11 to 20 range, those are going to be your resistant ones. So you can see here the frequency of entries back in the day in those SIU trials. You were looking at quite a few that were having a very resistant response to sudden death syndrome. Then you can see in 2007, still maintaining that profile of resistance, where most of them are to the left of that susceptible check. So producers had a lot to choose from. Then with the release of Roundup Ready 2, you start to see this sort of pattern where all of a sudden the amount of resistant materials out there are really starting to be reduced. And now you're starting to see there's a whole bunch that are available that are very susceptible to the disease. So when we get these resistant traits, what tends to happen is for a couple of years there, we potentially don't have many materials available for our producers to help manage this disease. By the time you get in 2009, you're starting to see that shift again, okay? And, you know, I think one of the things we have to keep in mind, and again, 2011, it's looking like that too. Sorry, I got a little bit of lag on my screen here. But making sure that we're keeping or paying attention to screening our varieties to SDS, because when we're looking at 2014 here, we got kind of this L-shaped curve, and really we want to see that pushed out further to the left. With you know, we don't do these types of screens anymore. It'd be nice if they were available, but they're not. So we're really sure what the current profiles look like, but I would bet that we're dealing with quite a few very susceptible materials out there with some of the newer traits that have been released in the last 2-3 years. And hopefully we're breeding for better materials here in the near future. Now, this Fusarium virguliforme, there are several different hosts that can basically allow this disease to grow and continue to proliferate. So these are crops that we want to make sure that we're not rotating our soybean with. Things like alfalfa. Again, these aren't really big here in Illinois, but the dry beans. But if you're thinking about cover crops, you know, thinking about clovers and vetches, those can host SDS too. So we got to think about that as we're starting to do more work with our cover crops as well. And even canola, actually, interesting enough, can be a host. Now, one of the things we are learning with this disease, typically we tell people, make sure you rotate your soybeans because that's going to help reduce pathogens. And on a large scale, that is absolutely true. But with SDS, we're actually finding that the pathogen can grow and actually sporulates better on corn residue. So if you're following so if you have SDS in soybean, follow that with corn, and then follow that with soybean, you'll actually likely have more sporulation, more of the SDS pathogen in your field than if you were continuous soybean. So one of the things we're starting to recommend now is if you are following corn, make sure you're sizing that residue or getting a good clean harvest to try to reduce the amount of residue on the soil and reduce the amount of population increase that might result from following corn production. Resistance, again, very effective. So here we're looking at a combination of, oh boy, I forget how many there were here, but these were 5 years of trials. You're looking at several dozen trials here, and these are just the overall responses that you see across those trials, including Illinois. So we see a significant reduction in our foliar SDS symptoms by about 82% or 81.3%, I guess is a specific number. And in terms of our yield here, we're getting a 15% improvement in yield. So this is when we're using a resistant cultivar and we're putting it in a field with a history of SDS. Come on here, there we go. Now, if we're looking at our seed treatments, right now there are several different seed treatments that are marketed for SDS. Our research across states and years right now, we have the most data on these two products, but they're also providing us the most consistent results, and that's why I'm presenting those here. So this is a summary of some of the work that's been done by our group in the Midwest. You can see here when you're looking at our FDX ratings, there's a 24% reduction in the foliar symptoms when using ILEVO or SALTRO, and a 21% reduction in root rot symptoms for both products. When we're looking at these products in terms of their improvement in yield, we're looking at about a 3% increase. Both of these products do fairly well, and they're very consistent in their responses. So that's why I'm talking about them. So they're both fungicides in that SDHI group 7 group. And like I said, in terms of the ones that are available, those are the ones currently we would recommend as a seed treatment, in addition to a resistant cultivar if you do have issues with SDS. Now, SDS, you have to keep in mind, like any disease, it doesn't show up every year. You really do need the conditions to be appropriate. In our case, we've had 9 trials since 2017 in Illinois in all sorts of different locations where we inoculate, we plant early, we irrigate, and only one had rateable disease this past year. In that case, the amount of disease wasn't very significant. So it's important that we keep that in mind as we're managing our diseases as well. It might not be that every acre needs a seed treatment, but we definitely should be thinking about the fact that this is a disease that really needs it cool and wet early in the season to take off. And how frequently that occurs, again, that's something we have to think about. But a lot of the data we have in Illinois over the last 3-4 years, you know, the yields and performance look a lot like this, where they're fairly flat. We don't really see any responses. And that's because we simply haven't had the types of conditions for severe SDS, at least where we've run these trials in the past. So hopefully, as we continue to generate data, we'll have more data on some of these other seed treatments and their relative efficacy. If we look at our trials from this last year, we had three trials, and again, we're seeing the similar responses when we're looking at our yield from our susceptible to our resistant cultivar, and you see that improvement from 62 up to about 66 bushels per acre. Our controls are at about 62 bushels per acre, and again, ILEVO and SALTRO statistically similar, right about 65.5 bushels. So our data are, again, corresponding to what the larger data sets say. These aren't silver bullets, but they can help improve your overall yields. They do come with costs to them. And that's one of the reasons why some people have been considering not including a base in their treatments. And now base fungicides will include other modes of action that can have activities on other important pathogens. It's not just SDS that can be an issue, and depending on the environment, one year might be one pathogen that's a problem, and one year might be SDS. So for example, fluopyram, the active in ILEVO, doesn't control Pythium or Phytophthora RHIZOCTONIA. So we conducted some trials where we were asking the question, what if we only had ILEVO, and then we had, you know, base or no base, and what would happen in that case? And so we conducted this at 2 sites in 2018. We either had a base that was Evergoal Energy and Allegiance, or, you know, we had ILEVO or no ILEVO on top of that. And then we measured emergence, yield, and disease. And in that case, at those trials, it was very favorable for RHIZOCTONIA development, but not for SDS. So what we ended up seeing is this kind of response here, where our controls had reduced emergence relative to include our base here. So you're looking at a 10 to 15,000 plant per acre reduction when we didn't include that base. You look at the ILEVO only, statistically similar, if not a little numerically less than our non-treated checks. So ILEVO is not controlling RHIZOCTONIA. We add that base and we're bringing it back up to that, you know, 70,000, 75,000 number that we were seeing when we had ours. Now, when we're looking at our root rot, significant reductions. Again, these kind of follow that same pattern. It's the base that's causing the reduction in our root rot that's caused by the RHIZOCTONIA. And when we look at this yield response, again, what we'd expect, we're seeing about a 10 bushel increase in these particular trials when we have a base fungicide included with or without ILEVO. Okay, so we do need to remember that SDS is not the only disease. There's other seedling diseases out there that can have significant impacts, and we want to make sure that we include that base treatment if possible, if we're making a seed treatment and including ILEVO. The big key here, make sure that everything is diagnosed properly. As I mentioned, there's lots of things that can cause intraveinal chlorosis. If you have SDS, make sure it's SDS, because some of these management practices, fungicide seed treatments, do not work on those other diseases that can cause those issues. Use of resistant cultivars is important. Planting into conditions that favor rapid emergence. So people want to plant earlier, that's fine. I just tell people not to get too crazy. We don't want those seeds sitting in the soil for 4 or 5 weeks. We want those seeds popping as soon as possible. And again, if you have an SDS problem and you have a resistant cultivar, the use of one of those two particular seed treatments, SALTRO and ILEVO, giving the most response, providing roughly a 3 to 4% improvement relative to non-treated seeds in SDS favorable environments. But don't forget to include those base treatments. And it moves me into my other pathogen here, again, RHIZOCTONIA. Now, RHIZOCTONIA is very prevalent throughout Illinois. It's caused by a fungus. There's many different species of them out there. One thing to keep in mind, they have wide host ranges, but the ones that infect corn aren't as aggressive on soybean and vice versa. Okay, so rotation helps to minimize the selection for individuals that are really aggressive on soybean. So that's why rotation helps in this case. They do overwinter in the absence of soybean, just like SDS does, but we want to make that we're not increasing the number of really aggressive strains in our soils. These are most problematic in really high organic soils and soils that are really warm in temperature. So wet, so think wet early, followed by like drought-like conditions or really hot temperatures. That's really going to favor this pathogen. Not saturated soils, though. They do actually need, this pathogen does need good oxygen exchange at the soil surface to grow and reproduce. In terms of symptoms, our seedlings tend to have the development of a canker that's a sunken lesion, and that sunken lesion is usually going to be at the soil line, and it sometimes can extend into the roots. The roots can be significantly degraded or even add on some of these. And also these cankers tend to have a red look to them, and they're kind of corky and spongy in their appearance. In terms of how it looks in the field, you're going to have emergence issues, and you'll have plants sometimes that can die up to B3, B4, depending on the conditions, okay? So, again, very prevalent in fields in Illinois, and warm seasons, it's going to be a problem. Now, in terms of management, I mentioned rotation. Resistant cultivars, we don't really have any. There are some that are more tolerant to this disease than others. This is because of the broad host range and the fact that they're just, this is just a pathogen that doesn't have, heritable traits for resistance in soybean that have been identified yet. Now, in terms of seed treatments, seed treatments can help with managing this disease as well. I'm focusing just on this particular trial this year, although if you go into our applied research guides that I believe are promoted here at the summit, you'll see some other trials we've done throughout the year for RHIZOCTONIA. This is a product from Valent. We did this trial this year, Zelterra. It's a new DMI active ingredient, and I just want to provide this information. This is something that will be available next year, I believe, even though there's labels going out for it this year. So in this case, we have inoculated with RHIZOCTONIA or not inoculated. So if you want to look at these blue bars, consider them controls. And then those purple bars are going to be your treatments. And again, if there's different letters, that means they're statistically different. So we're confident that those are real differences. Our Zelterra here compared to our Cruiser Max Vibrance and our Acceleron did significantly better in terms of the emergence. And again, you can see that impact of RHIZOCTONIA on reducing that emergence. Without including the RHIZOCTONIA, we're close to 90,000. We drop it by almost 30,000 plants per acre, even on these treatments with the Zelterra. Okay, so keep in mind, RHIZOCTONIA is not something to forget about. That's why we don't want to forget about those base treatments with SDS. In terms of yield, we saw a significant improvement as well. So you're going from about 61, 62 bushels per acre, 75 in these trials. Again, with RHIZOCTONIA, yes versus no. When you're comparing these products, we see differences relative to Cruiser Max and Acceleron. So this will be another potential treatment that could be put on for health, and I would say it looks pretty promising for RHIZOCTONIA movement, and the data look pretty good for this particular active ingredient. So another potential tool in the future. In terms of rhizoctonia management, there are several active ingredients and products. We have to keep in mind products have activity on rhizoctonia. Many of those common names, there's so many different names. A lot of these actives are off patent, so there's just way too many products to mention. But anything with azoxystrobin, fluoxypyrazide, and any of the ones here that are good, so looking at fludeoxonil, PCMB, penicillin, prothioconazole, those all do pretty well, as well as sedexane and trifloxystrobin. So when you're looking at your base treatments, anything that contains those active ingredients should have decent activity on rhizoctonia root rot, but they're not going to have activity on SDS. Okay, so keep that in mind. Now, Pythium, this slide is backwards. So Pythium is another organism that causes issues. This is an oomycete pathogen, so totally different from rhizoctonia and SDS. That means that the management practices and chemicals that control it are also going to be different. So this causes a mushy rot of our seedlings, and really, if you took your seedling out, and it's going to usually be in areas where there's kind of water saturation, you take that seedling out and you pull, if you run the roots between your fingers, that outer cortex will slough right off, and it'll leave this inner cortex like this remaining. That's called a rat tailing, okay? And then, so that's why this slide is over here. So usually we're talking about rat tails. This is what we're thinking of. So now when you're in the field, in addition to thinking of Shia LaBeouf and new Kids on the Block, you can start thinking about Pythium and what that looks like. It also causes a seedling rot, and oftentimes you're going to see this sort of symptom again. Very similar. Seedling disease, especially early in the season, it's so difficult to tell them apart from one another. You can have multiple diseases in the same field at the same time, and so it becomes really hard to diagnose what the issues are early in the season. And it also makes it really important that if you do have a seedling issue, you send it off to a diagnostic where you have somebody who might have different tools available that can detect the different pathogens, because management does differ for some of these, and we want to make sure that we're challenging the correct pathogens. So Pythium, it's a water mold. It's actually more closely related to algae. There's been some surveys done across different areas, and basically the take home here is each of these discs, each of those colors, and that, I guess, this pizza, right, represents different species of Pythium. All of these Pythium potentially can cause disease on soybeans. So you can see here, depending on the state you're in, you have a different makeup in terms of the different species that are present. This is also true within field to field. If I go in field A and field B in different parts of the state, they're going to have different quantities and species of Pythium present. Now, why is that important? Well, if we look at the way our species are, first let's think about this. We did some work here in Illinois. This is done by Daniel Serratos. He's going to be graduating this year. But you can see here, this is what we're finding in terms of our fields in Illinois. We have all these different species here. Looking at maybe 18 to 19 that were found just in these very limited surveys from 2017 and 2018. That's a lot of different species. Now, in this particular work, if you're looking at those species, these are all different species of Pythium here on the x-axis. These are looking at the impact of emergence at two different temperatures, either at, I believe it's 15 centigrade and 20 centigrade, or 60s versus 70s in temperature. We always said cool temperatures, wet conditions, that's going to be favoring Pythium. No, what's going to be favoring Pythium is wet conditions around planting. What you can see here is you have some species that can cause more disease. That would be red over blue, so high temperatures over low temperatures. And then you have some species over here that cause more in cool temperatures relative to warm temperatures. And you see there's kind of a gradient here in terms of your species from causing significant disease to maybe the lower levels of disease. So we have multiple species in a field at a given time that have multiple temperature optimum. So we have to keep this in mind. If we have wet conditions around planting, saturated soils, potentially we're going to have Pythium issues. Now, there are examples of Pythium with insensitivity or resistance to different fungicide active ingredients. Here in Illinois, Daniel was able to find a few isolates that were actually resistant to azoxystrobin. And this one's actually interesting. A couple of ice that are resistant to ethoboxam, which has only recently been kind of released on the market, and some that are kind of middling in terms of their resistance. So we do have resistance out there in addition to metalaxyl, which has been reported in multiple states previously. So we have to keep that in mind too as we're using seed treatments, the importance of mixing up our active ingredients. Now, this is kind of showing the same thing here. We're looking at metalaxyl, ethoboxam, and mefenoxam here. And we're looking at different isolates of one particular species. So within an isolate, they can or within a species, I should say, they can differ in how they respond to these active ingredients. So if this is a non-treated control and these are the different fungicides, you can see that there are different responses within these isolates, from one doing better than another to no difference in the different seed treatments. So that's what we have to keep in mind with these seed treatments, is that they can help, but especially with Pythium, it's a real challenge out there. We're dealing with a really diverse population, and they all respond differently. And I'll get through that slide there, just kind of showing the same thing but with different species. So in terms of our management, minimizing compaction, minimizing standing water, especially early in the season, that's going to help. That sometimes is easier said than done. Planting into warm soils, again, I say warm soils. The idea is get those seedlings out of the ground. The bigger they are, the more they can tolerate any kind of infection, even if it's later infection. Okay, so the soybeans can tolerate that. What the seedlings can't tolerate is infection early when they're young. Seed treatments have to have Pythium-specific active ingredients, and I list those here. This is an OMI seed. That means it is physiologically different from true fungi, and that's why we see, RHIZOCTONIA was controlled well by azoxystrobin. It isn't really touched in a lot of cases, and we even have resistance, right, in some of our species here. So these are the ones you're going to use. Mefenoxam, metalaxyl, ethoboxam tend to give us the best control right now in terms of the active ingredients for Pythium suppression. Phytophthora is the last one I'm going to talk about. Very similar to Pythium. It's a water mold. It's an oomycete. This one's a little bit different, though. We don't think about Phytophthora oftentimes causing a seedling disease, but it does. And a lot of times when in the past where we've used different tools to detect what's present on some of these dead seedlings, and we come back with Phytophthora, people say, oh, it can't be Phytophthora. It's causing a seedling disease, or I have resistance. Okay, we're going to explain here why you may or may not see that. There are two types or two species of Phytophthora that we see in Illinois. Phytophthora SOJAE, which is the really aggressive one that's just aggressive on soybean, and Sansemiana. Sansemiana isn't as aggressive. It also can go to corn, but it also can infect soybean. They both like saturated conditions, but moist or warm soils. Okay, they can infect through the season. When you're infected with Phytophthora SOJAE and you have a susceptible cultivar, that's when you can see those later season lesions and then the death of emerged, more mature plants. Okay, that canker that develops. You don't see that with Sansemiana. You do see that, however, in SOJAE. And I'm going to go back to that slide. So early season, the roots are often black. They usually fall off. You're not going to see that rat tailing. You're not going to see those cankers. But later on, usually after the seeds start to fill, R1, maybe even R3, you'll see this kind of lesion that goes from the roots up into the plant, up into the lower part of the stem, and it doesn't have a sharp margin on it. It looks kind of diffuse. That's usually a good characteristic of Phytophthora. Now, just comparing these two again, Phytophthora SOJAE, that's the one we're most concerned about. Causes the stem cankers, more aggressive. We know more about this because it's been around or it's been identified longer. There's resistance out there in our cultivars. Okay, it has both general resistance and specific or gene for gene resistance in the population. Sansemiana, less aggressive, doesn't cause those stem cankers, and also has multiple hosts. So they both can cause those seedling issues, but then they have different impacts in terms of what they do to the soybeans. Now, in terms of selecting resistance, there's two types out there. Field tolerance, this is going to be something that's, again, a qualitative trait. It's kind of like in SDS, right? Ranging in how effective it is. It slows the ability of a whole bunch of different races of this Phytophthora pathogen to infect the plant and then cause symptom development. So it slows those symptoms, and it helps improve the overall response to the different races out there. So one field can have many different races of Phytophthora in it. The issue with field tolerance is it's only active when the first or second true leaves pop out of the plant. Okay, so not the initial leaves, but the ones, you know, with the 3 lobes. You get 1 or 2 of those, then this is active. That means that early on, when that seedling is germinating, popping out of the soil, things are wet, that's when this isn't going to be effective, and it's going to be most likely in those stages that our seedlings are going to be most susceptible to having issues with emergence and that sort of thing. There is race-specific genes for Phytophthora SOJAE, only effective against certain genotypes out there. Okay, that means it completely shuts off some genotypes of Phytophthora SOJAE, but then there's going to be other ones in your fields that are going to be not affected by it, and they can affect or infect the plant just like that resistance gene wasn't there. But it's effective from seedling all the way up through adulthood. So if you have, you know, a lot of one particular genetic background in your field, the resistance can be very effective, but you're still going to get infection potentially. So sometimes this is how it's listed here: your field tolerance, you see your number here, and then your resistance gene. So each gene controls a different genetic population of Phytophthora SOJAE. Sometimes, if you're lucky, you'll get stacked genes where you get multiple ones. So think of these as like a premix fungicide, where you'll have multiple modes of action. You're more likely to have more of your population control. So we have a lot of RPS1K out there, and about 60% of the Phytophthora SOJAE isolates that Danielle isolated from Illinois are virulent on RPS1K. That means if you're using just a cultivar with RPS1K, you're likely to have 40% or so of your population of Phytophthora in a field that'll be unaffected by that particular gene. So it's important to rotate your Phytophthora resistance types, and maybe even go after some of those stack traits if Phytophthora is something that's been an issue for you in the past. Don't constantly go back to the 1K. Try to rotate that. And it's an issue that happened in STN soybean cyst nematode too. When we use the same sorts of resistance, eventually there's some issues there. In terms of our Sansamiana, we don't see any kind of response with Sansamiana to these RPS or genes. So they aren't going to have any kind of effect on Sansamiana. The field tolerance, though, can help, again. So you want to get something that has good field tolerance and some resistance genes. Seed treatments, right here we're looking at ethoboxam and mefenoxam. This is coming from a paper from Dr. Dorrance back, was released last year. And what you can see here is that ethoboxam is very effective for reducing seed rot caused by Pythium, Phytophthora Sansamiana and Phytophthora SOJAE. So in terms of another tool in your tool belt, it works very well. Metalaxyl and mefenoxam also are very good. I don't have data on oxythiopiprolin, but oxythiopiprolin for Phytophthora is excellent as well, but not for Pythium. So keep that in mind. If you're using oxythiopiprolin, it'll do great with Phytophthora, but your Pythium might not be affected. So you might think about something that has, you know, metalaxyl and oxythiopiprolin. There's a lot of choices you can have out there. So these are our scores here, and I kind of highlighted oxythiopiprolin. I will actually have the most recent soybean seed treatment scores that we put together annually, and I'll make those available here to IL Soy and the CCA group. I'll probably post them on Twitter as well. IL Plant Doc. That's my handle. So keep your eyes open for that, and you can download those, and it'll have all the different diseases, trade names, and the ratings we have for the different diseases. Now, in terms of Phytophthora management, it's my last slide here. So same thing as Pythium, right? We want to be improving our drainage. We want to be using a cultivar that has good field tolerance and RPS genes. And if we're going into a field with a history of Phytophthora, rotation of those RPS genes is going to be important. We're trying to find those with stacked genes. Those Phytophthora And again, keep in mind, RPS genes are effective throughout the season. The field tolerance kicks in after those true leaves start, so you're going to be most susceptible those first 3-4 weeks. That's where using a Phytophthora recommended seed treatment can help, and that'll buy you those 2 to 3 weeks of protection, hopefully up to that first true leaf, if those conditions occur that can cause problems. So anyway, that wraps up my talk for today. I think I have some time for some questions, I hope. Like I said, you can follow me on Twitter. You can contact me on my email, nathank@illinois.edu. I'll still be checking that. And for those of you that are in the FS system or any of those sister companies, I'll still be very active. The extension and research areas for Illinois and the surrounding region. And you can also contact me through the GrowMark email. I don't have one yet, so I officially start there in a couple days. So that'll wrap up my talk for today, and I'll take any questions you might.
No, thanks, Dr. Kleczewski. This time, we will be having the Q&A session for anybody in the audience. If you would, on your left-hand side of the screen, there's actually an icon that says Ask a Question. If you click on that, type in your question, and that'll get sent over to us, and we'll ask Dr. Kleczewski. But in the meantime, we actually have some that had already been submitted early. So, Nathan, I'll just go ahead and ask a few of these to you. But number one, from a particular grower, they farm soybeans on heavy sands, and they've always got issues with soybean cyst nematode. What are some recommendations you could advise folks on that?
So if you're dealing with soybean cyst nematode, the best thing you can do is avoid continuous soybean production. So if you rotate a single year into corn, research has shown you can have up to a 50% reduction in the SCN in your field. So you can't eliminate SCN. The idea is to keep those populations low so that they're not impacting your yield. So that's the first thing. The second thing is if again, this is hard to do, if you can rotate different sorts of resistance in there, sources, that's very effective. It's just like some of these other seedling diseases in that regard, where it's starting to become very, it can reproduce on a lot of the resistance that we have out there because we keep using the same source. If you can't get a different source, rotating cultivars can help because different cultivars have different, I guess, amounts of effectiveness even within that gene, so that can help suppress more. We don't necessarily recommend seed treatments, but we can say consider those. The data that have come out have been very inconsistent. I think Greg Tilka said about 10% of the trials, does he ever see a reduction in SCN and an improvement in yield? We just have to keep in mind, especially with biological controls, it's going to be variable just by the nature of those biological controls. And just similar to these other seed treatments we were talking about, you're looking at a 2 to 3 week protection window. Nematodes continue to grow and reproduce throughout the season. So if you're planting early, especially in the cool soils and nematodes aren't active, I wouldn't expect those to be effective at all. If you're planting later when it's warm, maybe a higher chance. So keep that in mind.
No, really great insight there. Early on in your conversation, as related to SDS, you referenced different beans having different susceptibility, resistance, and then we also talked about the different seed treatments. If you had a bean that had a lower SDS sensitivity, if you will, more susceptible, and you use a product like SALTRO or ILEVO that improved that, how comfortable do you feel putting that bean that's treated, even though it's low susceptibility, into a field that had history of SDS?
Well, the data show that there's, and this is a statistical term, there's no interaction between resistance and seed treatment. So when I was showing the bars in terms of the 15% improvement in yield with resistant versus susceptible, and then the percent improvement when we're using one of the recommended seed treatments, that would be additive, right? So if you're using a resistant one, you're going to have 18 potentially percent improvement over a non-treated no seed treatment. So you're going to have an impact. It can be an improvement 3 to 4%, but in a severe year, you're still going to get dinged pretty hard by it. So it'll still protect it, but that's why integration is really going to be the best bet. would I be comfortable? I mean, try to avoid that if possible, I guess would be my recommendation.
No, great insight. Early on, you talked about how seed treatments, different organic matters are going to collect it and can, impact the effectiveness and longevity. As we're planting soybeans earlier, and the seed's going to be sitting there for a longer period of time before it actually germinates, how much risk is associated to the seed treatments to where, based off average rates, or are we getting our protection there? Or should we start looking at higher rates by planting earlier?
Some data out there, again, it's going to be dependent on what organism, but especially for Phytophthora, that can be a benefit of a higher rate if you do have some serious issues out there. If you're going in really early, and you think you're going to be coming into more situations where you could get nipped in the butt, that higher rate could provide you a little more protection. But just keep in mind, they're not, like I said, they're not going to cure a seed that can't germinate because it's dead, and they're not going to allow your seeds to survive drowning in the soil as well. But definitely with high organic matter soils planted early, there might be an additional benefit of a higher rate in some cases. So you might want to consider that.
Okay, good insight. As we look at seed treatments that have inoculant, whether they're treated, all in one slurry, or inoculants treated later, do you see any issues with the inoculant being in with the treatment? Is there any interaction there?
Not that I've observed, or not that anyone else that I'm aware of has observed. A lot of those inoculants are bacteria, so they shouldn't be affected by these fungicides. And I guess that's one potential good thing, about those inoculants. We're not inoculating with fungi. So let's see.
What's your thoughts on having any of the active ingredients that we referenced today? There's maybe a desire to put more in furrow into a liquid system. How safe are those active ingredients going into an in furrow system that close to the seed?
Yeah, so again, it depends on the active ingredient. Some of those are going to be pretty darn hot, as we know. Like, for example, fluopyrin can burn up your seedling. Some of the DMIs can as well. One of the things I think about within furrow is a miscalculation on the applicator's part, where you go in, and I've done this accidentally in some of my research, where we've miscalculated and we've put a headline on in furrow and just burned. I think we took like a 50% yield hit on those trials that year because we really destroyed our seeds. So, I do say you can do it where there's a label. Make sure you follow the label. And some of those 2x2 placements and some of these other systems might be something to think about too, as opposed to just putting it directly over the seed, just for safety's sake. But you might want to play around with it before you completely transition into doing that with all of your products. And the nice thing about getting them treated is that they're treated commercially, and the rates should be correct, and the amount of toxicity issues should be minimized.
Gotcha. Next question relates to some of the Phytophthora plots you're referencing. The question is, were those natural populations, or were those inoculated with the pest?
The surveys. The surveys were that's all just in the state. So those are just going out to fields where there's actually, the way those surveys were conducted was Daniel just went out and found fields that had saturated spots with seedling issues, and then baited out the different Pythium and Phytophthora in those fields. So those are just what's out there. In terms of the data that I showed from Dr. Dorrance, she tends to use naturally infested fields in Ohio. And I don't think there's any specific type of profile that's out there in terms of the genetic background of the pathogens. But one thing to keep in mind is that some of the work where they have looked at different genotypes is they all respond similarly to the different fungicides. So it's not like one population is less sensitive than another in terms of Phytophthora.
Okay, thank you. Okay, well, based off our time here, Nathan, I think we're about in for the amount of time we have for the breakout session for today. Do appreciate all the questions and information that you definitely provided. But I'd like to remind everybody in the audience that if you are a CCA, don't forget to claim your one CEU in crop management for this session. You can either scan the QR code on the screen using your app on your phone, or you'll be able to email your CCA number and completion of the class to ilsoy.org, as you can see there on your screen. So with that, I would like to thank Dr. Kleczewski for his presentation today, and thank you for attending today's breakout session. Don't forget to tune in next week for the Soybean Summit event on Wednesday, February 17th, beginning at 9 a.m. Thank you.
Thank you, everybody. Have a great week.